Hello guys, today our topic is about the algebra and graphs for. Okay, so it's the first lesson of algebra. Okay, so the first topic is about linear inequalities, right? Okay, so last lesson we already learned about the linear equations, but what about linear inequalities? Okay, so maybe this will be confusing a lot because linear inequalities most of the time does not appear in our papers a lot, or like their frequency is very low, right? Okay. So here, I will introduce you the inequalities using the algebras. Okay. So we knew that for inequalities we can use in the number theory, right? We knew that like for numbers they can compare with each other. Okay. But variables or like here you can find x can also compare with a constant number like here x smaller than 5. That means x is strictly less than 5. Or also, we can, in other words, you can say like x cannot equals to 5, but x is indeed smaller than 5. Like x can be equals to 4, 3, or like other numbers, right? This is the first term right here. And maybe for the second term is that x bigger than 5, that is x is strictly greater than 5. So x cannot be chosen as 5, but x can choose 6, 7, or more for x, okay? That is it. And the third is x smaller or equal to 5. That means x is less than or equal to 5. So x can be chosen as maybe for a very precise value as 5, or x just equals to 5. And also you can choose x smaller than 5. Okay, x smaller equals to 5. And another is x bigger equals to 5. That means x can either choose x equals to 5 or like x can be bigger than 5, like 6, 7, or some other numbers. Okay. So here we are using an axis to represent for it. We can find here the example for x bigger or equal than -1. Okay. So here we can first draw on the x coordinate, right? We are using a closed circle to represent for it. It means that we can choose this point. So like here you can find x bigger or equal than -1. So first we just use a closed circle to represent for maybe here x can equals to -1. And then we draw an arrow right here. You can find the arrow is to the right, right? Okay, you can find here, arrow is on the right place, toward right. Okay, so now you can also say maybe here, arrow is on the right, so x can be bigger equal than -1. Okay, so x can choose 0, 1, 2, 3. Is there any range for these arrows? Okay, that is for this example. And here is how we solving the linear equations. Okay, so here you can find first example is about 3x plus 4 smaller than 19, right? First, you can subtract 4 on the both side. So here is 3x smaller than 19 minus 4 is 3x smaller than 15. Then you can both divide the side by 3. So that is x smaller than 5, okay? So in finding the solution, it means that x is strictly less than 5. So by using a coordinate, you can draw like this. Here is a 0 point, or like a original point, right? And you can label a -5 right here. And then you can label like here is just a circle, but it's not a closed circle, right? And then you can draw the label, draw the arrow on the left. Because it's, oh sorry, here's 5. It's not -5, right? Okay, sorry for that, okay? So maybe here we have to draw like this. 5. And then we have to draw like this way, and we can find here this arrow, right? That means x is smaller than 5, okay? Or strictly smaller than 5. Okay. And here are some negative rows. It's very crucial and very important for you to remember, okay? You can find here example about 10 minus 2x smaller equal than 4. So first we can subtract 4, subtract 10 on each side. It becomes -2x, and 4 minus 10 is -6, right? Okay, so it's -2 times x smaller equal than -6. And then you can divide it -2 on the both side. Okay, but remember here, because you divided a negative number, so here maybe the inequalities symbols has to flip in another side. So here we flip smaller equal to bigger equal. So here the final value is x bigger equal than 3. Okay, that is a negative rule. And here's how we solving the double inequalities. We are also using like dividing into two parts. So here you can just oh, maybe first we can just eliminate about the constant number -1, right? First, you can add 1 on all the three parts. So that is -5 smaller than 2x minus 1, oh sorry, -5 plus 1 smaller than 2x is also smaller or equal to 7 plus 1. So the final answer just changes into this form. 94 smaller than 2x, smaller or equal to 8. And then you can divide it all three parts by 2. So here you can find it just changes into -2 smaller than x, smaller or equal than 4. Okay? So which means that x is strictly greater than -2, and also you can find it smaller or equal to 4 and up to and including the 4. Okay? That is for this value. And also here is some deliberate practice for you. If you want to just try on yourself, you can first pause the video and try to do on yourself. But if you want to follow his teacher Mai Lin, you can also just keep on going, okay? So let's move to the first question, like here, 5x minus 3 bigger than 12, right? So first in this equation, inequalities, you can just plus 3 on the both sides, right? Because you just want x or the variables on the one side. So it just turns into 5x bigger than 12 plus 3, it equals to 15. So now you can divide it by 5 on the both sides, that is x bigger than 3. That's the first term. And the second question you can find here is 4 times x plus 2 smaller or equal to 3x plus 11. And first, you can just expand the brackets. So that becomes 4x plus 8, right? So here's 4x plus 8, and smaller or equal to 3x plus 11. Okay. And then you can put x on the one side. So here you can find is x smaller or equal to 11 minus 8, okay? So here it equals to 3. That means x is smaller or equal than 3, okay? And if you want to use a coordinate to represent for this, you can just draw a coordinate, and here's original point, here's 3, and use a close point to represent for it, like, and using a arrow to the left, you can find here that represent for this maybe inequalities, okay? And for the third problem, you can find here is 7 minus 3x bigger equal to 1. So first of all, you can just minus 7 on both sides, right? So that it becomes -3x, maybe is bigger or equal to -6, right? Because 1 minus 7 is -6, right? And then you can divide it -3 on the both sides. So it becomes x smaller or equal to 2, okay? So you can find the inequality symbol is now flipped, right? Okay, it's from bigger equal to becomes smaller equal. So remember, every time if you just times or product a negative value on the both sides of the inequalities, remember to flip it, okay? So it's x smaller equal to 2. And the question is find the largest integer x that satisfies this. So we can say that maybe x equals to 2 is the largest variables to satisfy this, okay? So maybe x can also choose 1, 0, -1, or others, but the biggest value or biggest number here is 2, right? That's the third problem. And for the fourth problem, you can set first we -1 on the both sides, right? So it becomes -9 because -8 minus 1 is -9, smaller equals than 3x, and then smaller than 9, okay? And then like you can like maybe for divide it by 3 on the all the side, right? That is -3 smaller equals to x smaller than 3. Okay, that is the fourth problem. And the fifth problem draws the solution of x smaller than 2 on the number line. So first you can draw the number line x this way, and you can find here that is 2, and x smaller than 2, you can draw an arrow to the left, right? And also remember that here is like a hollow circle. It's a hollow circle, okay? That is very important. Okay, that's for our lesson. We already maybe reviewed all about the linear inequalities. They are very important, and I hope you can just trying to know how to draw them or sketch them on the axis right here. Okay, so that's for today's lesson. See you next time. Bye.